Good afternoon, everyone. My name is Jay Dhaliwal, and I'm the founder and CEO of Vox Life. And I'm so honored and pleased to be here and for being invited to speak at the online wellness summit. I want to give a special thanks to Trish Rossiter and the organizers for asking so many esteemed speakers to join over the next few days. And as you've been listening and watching to the presentations, I'm sure you're as impressed as I am about so many of the different and new advances in wellness and healing that are available to us, for our families and our patients and our clients. When Trish first reached out to me, she asked if, Jay, can you share a little story about the history of Vox Life and the technologies that we've developed here. So I want to take some time this afternoon to do two things. First, share the genesis of Vox Life and our haptic technologies, and then really jump into the development of our technologies and what separates what we've done as opposed to some other solutions available on the market, but really anchor it down to the science of what's triggering the amazing responses we see with the Vox HPT technologies. So where do we begin, right? People always say, what's the story behind the story? For Vox and for myself, my interest in neurology began at a very young age. At the age of 13 in 1983, my mother was diagnosed with multiple sclerosis. And as many of you know, MS was a black box then of understanding of what caused it and the potential treatments for it. And for many, it's still a black box today. And over the last now almost 40 years, I've been studying neurodegeneration, neuroperformance, what causes our neurology to work well, what causes our neurology to stop working well. And in taking my mother to specialists all over the world that specialize in neuro rehab and or MS, we kept running into the same roadblocks, sometimes glimmers of hope, but no real movement forward or no real progress in terms of helping her regain some of the vitality, much of the vitality that she had lost. And what I learned over 30 plus years was that many, many solutions for neuro rehab and neurostimulation and neuro recovery go down three major branches of mainstream treatment and mainstream medicine. The first, I think we're all familiar, is some kind of chemical intervention. It's a mainstay of our health care systems, where different combinations of chemicals are put together in order to help provide relief. The other major component, or the major track of neurorehabilitation, is some kind of electrical stimulation. I think we've all heard of or seen implants that are used to stimulate the nervous system. Sometimes they're cranial implants that go into the head. Other times they're in other parts of the body, whether the spinal cord or in the chest area, going into the vagus nerve. And finally, and perhaps drastically, the third intervention that's looked at and evaluated is surgical, some very invasive procedure to help, perhaps that could help provide some relief. My mother tried the first one, the chemical intervention, wasn't a fan of it, didn't really give her the relief. There was many side effects to it. She was not interested in surgery, and she was not interested in any implants or any type of thing. So once you start realizing that the options were limited for us in terms of what we wanted to approach, I decided to take a different approach to understanding neural communication. So by background and education, I'm a software engineer. I studied and developed encryption systems for a long period of time. And I used a very different approach to understanding how our nervous system and our central nervous system communicates, how it breaks down in terms of communication breakdowns, and how those communications are, number one, generated by our system, by our bodies, by our nervous system, by our biological system, and then interpreted by our central nervous system. And it's been a very interesting journey, a very rewarding journey in terms of understanding and our ability to develop solutions. and I'm actually very excited to share with you today our approach and what we've been able to develop. And so I hope you're as excited as I am to share this. So I'm going to start my presentation here, and we'll get started. Here we are. I'm going to make this just a little bit bigger. Put it in the corner here. So from skin to brain, the science of Vox Life. And if somebody wanted to give a name to our technology or put it into some kind of context, what we have with Vox Life is we've developed the haptic technology, a vibro tactile technology that stimulates the skin to get a very specific response from the central nervous system. And those responses, depending on the stimulation we're providing, provide for waterfalls of wellness and quality of life improvements for the users. So let's get started. So optimal neurology and our health. As many of us on at the seminar know, that the human body functions at optimal efficiency when the networks managing our body and our mind are in balance. So the autonomic system is a part of our nervous system, which is responsible for regulating all of the things that we don't think about. So our sense of balance, stability, our digestion, our respiratory response, our balance, our pain management, all of these things that we take for granted are all regulated by the autonomic system. Because imagine how complicated life would be if we had to think about all of those things, right? And there's this integrated communication structures that regulates the variety of body processes that take place without our conscious effort. So this is very key. Now, genetics, injury, illness, drug, stress, and other issues and factors can compromise a system. Misalignments within the communication networks can trigger dysregulations in how our neural networks manage these functions. So meaning to say, if there's a disruption in the central nervous system or in our peripheral nervous system in terms of how information is going to our central nervous system or how it's being processed or how it's being output, an individual will see challenges in their wellness and their quality of life. So how does our neurology impact our health, right? So we say, hey, it's optimal neurology equals optimal health. We also like to say a healthy body needs a healthy brain. Right? And so there's a concept in neurology and in biology and in biochemistry and in biophysics called homeostasis, which is a sense of balance, okay? So when our neurology is out of balance and it's not functioning optimally, we're going to have challenges with aches and pains, headaches, vertigo, sleep issues, digestive issues, blood pressure issues, decreased energy. We might even feel numbness. There's respiratory challenges, fatigue issues, sometimes depression, even hormonal balances can happen. And when our neurology is in balance or reaching balance or striving for balance, striving for homeostasis, and it's functioning optimally, we're going to see optimal neurofunction. We're going to see increased performance in our ability to move and our mobility. We're going to have less or limited pain. Our posture improves, our stability improves, our agility improves, our digestive improves, our sleep quality improves, stress headaches disappear seemingly. We have more energy. And even at a biochemical level, this hormonal balance is achieved. And what's great about this is that there is a pyramid that we work through in terms of our physiology. At the base of that pyramid is the biomechanics, the biophysics, how our legs move, how our arms move, how we stand, our posture, all of those things. Above that base is the next level, which is the biology, right? meaning how are our organs working, how are they connected, how is all of those different things that are connected to the biology of our body. Above the biology is the biochemistry, right? And the biology affects the biophysics, and the biochemistry affects the biology. And the chemistry is the quality of cell content, how well our cells are working, how our plasma is the health of our blood, all of those different things that affect our chemistry. So our neurotransmitters, all the different things that affect our body's chemistry is the next layer toward the top. And finally, at the very top of the pyramid of our physiology is our neurology. And neurology will impact every single aspect of that pyramid. It'll affect our chemistry, it'll affect our biology, and it'll affect our physics. Okay. And we propose, and I think everybody will agree, that to affect the biggest amount of change, we have to focus on improving neurofunction and helping our neurology reach optimal function, or help it reach homeostasis. And what comes from that is an amazing waterfall improvements in the biochemistry and the biology and the physics. Some of those things happen very, very fast. Some of them take a little bit longer. So, a unique approach to a common problem. So our solution proposition for the world is based on the premise that maintaining optimal neurology is the foundation to achieving and maintaining optimal health. So the path to a solution: what's optimal neurology? How do you define it? How do you identify it? How do you measure it? And then finally, how can you help it? So if we're looking for optimal neurology, how do we know when we find it, and what are we going to do about it? Okay. So measuring optimal neurology. So the gold standard for normative EEG, which are brainwave readings, is the Loretta database in Zurich. Now, this database has been curated now for decades. It's hundreds of thousands of EEG readings, and it's recognized as the most comprehensive database available for research for comparative EEG analysis. And what it provides for is a normative database that allows researchers to review it and compare their own data against it to see and look for neurological understanding in their research, to see different interventions, what impact they're having, to classify neural networks. There is an entire field of study based just on EEG studies. It really is the backbone of EEG studies and biofeedback research. That's how important that database is. So our approach and understanding, it was really based on understanding the fundamentals of neurocommunication. So what I developed over a number of years were proprietary algorithmic analysis tools and filters, leveraging Fourier transforms and other mathematical constructs that analyzed hundreds of thousands of sets. So what these were filters that allowed me to deduce very basic and critical neurofunctional networks in our neurology that are the baseline of our functioning neurology, of what's similar in all of us, right? And the approach and development process revealed two remarkable understandings and proprietary breakthroughs for us. So the first breakthrough through a solution is something that I call the neurodevelopment sequence. I proposed that because of the complexity of our neurology, because of the complexity of how it starts from a very, very small microscopic particle, from a neural groove, it becomes our brainstem, and from our brainstem, it becomes our central nervous system, our spinal cord sprouts, and our entire peripheral nervous system develops. And it develops very similarly for all of us. So I proposed, and I thought to myself, there had to be a sequence of this development because of the complexity of it. And the development of the brain and its process from the neural groove to adulthood is an innate process, meaning that it's pre-programmed in us. But we also believe that it can be compromised by genetics, injury, illness, drugs, tests, and other factors leading to neurological and physical challenges. So applying these different algorithmic filters and machine learning, we were able to decode this sequence as a set of complex neurosignals. So what does this mean? We applied machine learning and algorithmic filters to the largest data set of EEG readings. And what we were looking for was a commonality of what managed the development of our neurology. And this process took years. This wasn't a short process. This took a very in-depth look in terms of understanding neural coding, neural decoding, my background in encryption and computer coding and neural networks helped significantly to give us insight in terms of being able to develop those things. But this was our first breakthrough in understanding what this neurodevelopment sequence is. The second breakthrough was really tied to the first breakthrough. We hypothesized that if there was a neurodevelopment sequence, that there also needed to be a regulatory process that governs the development sequence. So what I proposed was that because of the complexity of the neurodevelopment sequence and the complexity of our neurosystem, our neurology and our nervous system, from central nervous system right down and through our peripheral nervous system, that there needed to be a regulatory process that managed those complex networks and those complex operations. And again, developing tools and algorithmic filters, we were able to decipher and decode this process as a set of, again, different neurosignals. This really is the heart of our HPT technology, these breakthroughs. It's proprietary. We don't share those tools, and we don't share publicly what we deduced and our exact process of doing it. So the question is, when these neural processes are outside of normative function, so we could see this complex set of neurosignals, and when they were within normative operation, the person generally had pretty good normal functioning physiology and neurology. When they were outside of those normative and optimal function, we saw issues of autonomic function and other quality of life challenges. So the question was this: we concluded that if the correct neurosignals could be generated in a non-invasive process, they could greatly compensate for dysregulated NDS and NRP, leading to normative function of neural networks and the autonomic system, leading to optimized homeostasis. So meaning, if those neurosignals were compromised, we proposed that if we could correct those neurosignals for the neurodevelopment sequence and the regulatory process, we could help that person, we could help that neurology correct itself. We would see corrections in movement toward homeostasis and corrections in the autonomic system, leading to optimized neurology and ultimately optimized health. So we went about trying to devise a solution how to do that. And because we know that maintaining optimal neurology assists your body to achieve and maintain optimal health, the best possible health is through proper balance and homeostasis. So there's decades and decades of scientific literature that strongly suggests that haptic perception and vibrotactile stimulation would reduce the flight or fight sympathetic response when it isn't needed, allowing the body to rapidly restore its natural homeostasis or balance. So what I'm saying here is this: there are many, many, many papers over many, many years that are showing that stimulation of the skin can have a very drastic neurological response, helping the body as a coping mechanism, right? So which informed me that it was very possible to send very complex signals through the skin that would then be interpreted by the brain. This wasn't my research, this was research that already existed. But it was fundamental in understanding that there was already research out there that looked at haptic perception and vibrotactile stimulation in terms of the impact that it could have on people's nervous system and ability to cope, which was just the beginning, right? So from skin to brain, the science of haptics. So sensation is an input about the physical world obtained by our sensory receptors. Perception is the process by which the brain selects and organizes and interprets these sensations, okay? So what we had proposing for a long time was that our brain could, first that our skin could generate very complex signals. And then two, our brain could interpret them, central nervous could interpret them and then put an output through. Recently, there's been a name that's been given to this theory and this science, and it's called the pattern theory of haptic perception, okay? And that really is the grounding, overall arcing theory and science behind our technology. It's the pattern theory of haptic perception, and what this theory explains is how the brain interprets information from the somatosensory system as a whole, The sensation we feel is essentially first created through a specific pattern of nerves that are activated and then eventually decoded by the brain. It was first proposed as a study on pain and itch perception. And the theory states that pain signals are sent and perceived by the brain when a specific pattern combination of receptors are activated. There are no unique or specific circuits for any distinct sensation. Instead, sensations are encoded into signals, resulting in the designated perceived sensation. So in very basic layman's understanding, the pattern theory of haptic perception proposes and shows in their research that our skin and the receptors in our skin and the free nerve endings in our skin can generate very complex signals collaboratively that are interpreted by our central nervous system, right? Which means a ton to us because we understand that if we can generate those signals that compensate for a compromised development sequence or a compromised regulatory process, we're going to be able to do some amazing things. But the core of the basic overall understanding is the pattern theory of haptic perception. So what do? We hacked it. Hacking is a word. There's something called biohacking and neurohacking. We were hacking the neurosystem 12 years ago. So we used neural decoding of the human hack response, the pattern theory of haptic perception, and frequency interference math to use free nerve endings and receptors to generate compensatory signals for compromised NDS and NRP. Once we had deduced the proper sequence of receptors, so we needed to decode and deduce which receptors we need to touch and activate through vibrotactile stimulation that could help generate NDS signals and NRP signals. And once we had those deduced, we encrypted them under a biometric image of a fingerprint to protect the intellectual property. Okay, so that's what our technology does. Our technology leverages the theory of haptic perception and just some high-level math, frequency interference math, that allows us to combine and mix neurosignals to generate compensatory signals for compromised neurodevelopment sequences and neuroregulatory processes. That's the magic. That's what's causing all of those amazing things to happen. And so when these receptors are activated by the pattern we've built into our products, we are actually making up for a compromised NDS and a compromised NRP. And because it's decoded, because the brain already knows what those signals are, it decodes them and the output starts happening immediately, right? So what's the difference? So VoxLife HPT, it leads to a more balanced brain. It leads to a more balanced neurology in our networks. It allows our brain to perceive and output better neuroinformation that is passed through our central nervous system and down out through our peripheral nervous system. So it helps our neurohaptic system generate compensatory signals that help our neurology and physiology reach and maintain better homeostasis. Because remember, we talked about that. At the very top of the physiology pyramid is neurology, then it's chemistry, that's biology, and then it's physics. And when we're impacting the very zenith of that pyramid and getting those results, that's where we're going to see all those amazing things happen in our physiology, in our movement, in our balance, in our biochemistry, and in our biology. But we have to go to the command center first, which is our brain. So how does it work? It's real simple. The technology and the pattern triggers a response. That response is decoded by our central nervous. It affects the body, and then we feel the difference. The effect is instant, ranging from improved balance, mobility, pain management, to better energy levels. Maintaining optimal neurology assists our body to achieve and maintain optimal health. So the analogy that I like to use sometimes is the garage door opener. We all know, we all pretty much all have a garage door opener. We press the keypad on the outside of the garage. We have to punch the right code in, but the processor to recognize that code is not in the keypad. The processor that recognizes that code is inside the garage, inside the motor there. So when we put the wrong code in, nothing happens. When we put the correct code in, the motor recognizes that code and says, oh, that's the command to open the door. And the motor starts working. So the keypad is our socks and the pattern on the socks. The sequence of the numbers is HPT. Our central nervous system is the motor inside and the chip inside the motor inside the garage. And so people say, well, is the pattern HPT the fingerprint? No, the fingerprint is encoding HPT. HPT is the sequence of and combination of receptors that we know. HPT is the neurosignals that we're generating through stimulating the receptors on our body, right? And so that's what HPT is. The rest is just the physical part of triggering that response. So whether it's the patch or the socks, it's triggering the response that we need. It's triggering the right combination of receptors that we need to elicit the response that we want that'll lead to ultimate wellness. So optimal function through optimal neurology. So we've done a ton of research and continue to do research. So our research shows improved balance, improved stability, improved power and strength, improved pain and discomfort management, and improved neural wellness. There's a number of studies on our website and more to come. Recently, at the Canadian Orthopedic Association's annual convention, two of our lead investigators, Dr. Michael and Karen Wolfrey, presented the findings of their study on total knee arthroplasty, a total knee replacement study. And what their study found was that with an intervention with our socks in rehab, where every patient had the same surgery in a sense, they had the same physiotherapist, they had the same recovery protocols, they measured it over a 6-week period, baseline 2 weeks and 6 weeks. They saw a consistent improvement in better pain management, in reduced stiffness, and improved functional mobility. And the key to that is that this was a randomized controlled trial. The abstract's going to be published next month in the Journal of Joint and Bone Surgery, the British edition, which is one of the foremost and leading peer-reviewed journals for orthopedic surgery. So we're very happy and very proud of that. I think it's pretty much a watershed moment for us, where we can take that and take it to our rehab partners and take it to all of the people that are working with people with mobility and OA issues and recovery issues and say, hey, here's a solution, a non-chemical, non-drug-based solution that can help people with their recovery, and the results speak for themselves. So we're very, very excited about that. So our products with HPT, as many of you know, they come in patches, they come in socks, knee braces, insoles, a wide variety of products. And we have a commitment to making the products easy to use, and we have a commitment to making them accessible. So we always trying to work to keep the price affordable, because wellness, we believe the world deserves an opportunity, and the world deserves real solutions at an affordable price. And so we're very much committed to that. And so there are a ton of research reference papers that we've referenced as part of the study. So I'll stop sharing here, and I'll be around online if you have any questions like that. I'd love to answer them for you. But I do want to thank you for participating today and listening to our presentation. Again, thank you to Trish and the entire organizers of the Wellness Summit. So proud of all of you for doing this. It's needs to be done more often. There's so much great information that the world needs to hear. And I hope that is just the beginning of a great regular an event for all of you. Thank you for listening, and I hope to see you in person very, very soon.